Hi, welcome to another edition of Admiral Science. I am your host, Mr. Allen, and this is your favorite TV show. Today we're going to talk about solids, liquids, and gases. And let me remind you that if you need to pause it, if you need to stop it, feel free. If I'm going too fast for you, stop, pause, rewind, get what you need to get. Do not stop or do not go on if you do not fully grasp it. Stop, pause, rewind, so you can get some things that you need. Alright, so as we discuss solid, liquids, and gases, we need to understand that matter is anything that has mass and takes up space. Alright, remember, matter is anything that has a mass and takes up space. Alright, and we've been classifying matter in different ways. On our last segment, we classified it by elements, compounds, and mixtures. And we even broke down compounds into inorganic or organic. And organic means that it has a carbon and hydrogen in its formula. It has both in its formula. Mixtures are heterogeneous or homogeneous. Heterogeneous are mixtures that can be separated. You can see the definite different types of materials in the mixture. So, like, for example, in these M&Ms, we see that we have orange, blue, green, yellow. We see in brown, we see different colors. So that's a heterogeneous mixture. Homogeneous means it's uniform throughout. That means that you cannot really tell where one meets and the other one ends. All right, so here we have a mixture of flour and water, and we cannot tell where the flour is separated from the water. So this is considered homogeneous. That means it's same throughout. It means same. Hetero means different. You can see different things. In homogeneous, you can see one substance. Alright, but wait, there's more. So now we can classify matter by solids, liquids, or gas. Alright, here's our composition structures of the solids, liquids, and gases. Alright, for now, we're going to say that solids have a definite or fixed shape. We can measure the shape of a solid. Alright, we can also measure the volume of a solid. Alright, so we can measure the shape and we can measure the volume. That means it has a definite or fixed shape, has a definite or fixed volumes. And contrary to popular belief, solids are always moving. Solid particles are always moving, just like gas particles and liquid particles are always moving. No matter what, particles are continuously moving. But in solids, particles don't have a lot of space to move in. So what they do is they vibrate. They're constantly vibrating. Every point of matter that is a solid is constantly vibrating. Alright, liquids do not have a definite or fixed shape. You can't measure the shape of a liquid because liquids have no shape. Alright, but they do have a definite or fixed volume. We can measure the volume of a liquid simply by using a graduated cylinder. So liquids have a definite volume but do not have a definite shape. Particles are moving in a fluid motion in a liquid. So liquids have spaces in between them. Unlike in solids where everything's so tightly packed, liquids have a space in between them so that when they move, they don't vibrate. They just simply have a fluid style motion because they are able to move a little bit more fluidly around. They have a little bit more space to move. Alright, in gases do not have a definite shape or they don't have a definite volume. So the gases are the loose particles. They spread out until they distance themselves away from all the other particles. So they distance themselves away from all the other particles. Alright? So we can go from one state to the other state. Alright? So we can go from a solid to a liquid to a gas, or from a gas to a liquid to a solid. So when a solid goes from a solid to a liquid, it is melting. Alright? So when a solid goes from a liquid, it is melting. When a liquid goes to a gas, it is evaporating. Alright, so a solid to a liquid is melting, a liquid to a gas is evaporating. And in the reverse, when a gas goes to a liquid, it is condensing. And when a liquid goes to a solid, it is freezing. Alright, so, and we can also go from a gas to a solid, or from a solid to a gas, and that's called subliming. Alright, so again, when we go from a solid to a liquid, it melts. A liquid to a gas, it evaporates. So this is temperatures increasing, and this is temperatures decreasing. from a gas to a liquid, condensing, and from a liquid to a solid, freezing. So let's look at it how it deals with water. All right, so water melts from a solid to a liquid. It melts at 0 degrees Celsius. And then water boils at 100 degrees Celsius. That turns into a gas called vapor. But the reverse is also the same thing. So water goes from a gas to a liquid by condensing, also at 100 degrees Celsius, and from a liquid to a solid, it freezes also at 0 degrees Celsius. So the temperatures will be the same for melting and freezing at 0 degrees Celsius and for condensing and boiling at 100 degrees Celsius. It just depends on which way the temperature flowing. Is the temperature going up or is the temperature going down? Alright, so if it's going up, it's melting, then boiling, and if the temperature is going down, it's condensing and freezing. But the temperatures are the same. 0 degrees for melting and freezing, 100 degrees for condensing and boiling. Alright, here we have it again. So these temperatures are the same, these temperatures are the same, and these temperatures are the same. So we know that freezing and melting is 0 degrees Celsius. Freezing and melting are 0 degrees Celsius. Evaporating or condensing, that means going from a liquid to a gas, it is 100 degrees Celsius. Alright? So these temperatures will be the same and these temperatures will be the same. It just depends on which way is the temperature going. And this has been a quick edition of Admiral Science. I look forward to hearing from you soon. And don't forget that this is a note sheet to go along with it, so make sure you do the notes.